few hours twice a week, sort of building out some code and talking about things that sort of pop up.
Yep.
Joseph's back, which is good because he was helping us with some stuff, I think, the last time, right? Which is good. And all this code's publicly available for you to be able to download and play. So as usual, we're going to have to go and look at where we are, open up the whiteboard and get a sense of, I remember now we were hacking.
Yes.
Ugly hacking.
Yes, we have to go
on
through.
the client there. We're going to have to, I mean, this project's more about the server than the client, so I didn't mind. But at some point, we're going to need a decent client to play with. But this is the thing, right? We got to pick what we want to work on. I know I want to write some tests. We could definitely write some tests for that chat package, even though it's doing WebSockets. Which is not, in my brain, I just want to get more functionality done. But that can also be dangerous because then you tell your manager, hey, I'm done. And you say, why did you say that? You didn't write the tests. You didn't. Now they want you to put it in production. So you got to be really careful what it means to be done here. But let me switch back over here. Let me see. Oh, yeah, here's our project right here. I feel like the TV's a little closer, but that's good. I'm getting old, man. So, yeah. Okay, so if we go to the app layer domain chat app again, this is kind of where we've been leaving notes. You know, on most projects, I actually leave these types of notes at the top of main. And even while I'm developing, even on a team, if there's things that come up that you don't want to work on right away, the best thing to do, actually, I want to move them, is to sort of put them here. Because sometimes you come up with something that you need to do, but you're not really ready to do it yet. And what happens is you just don't want to lose it. And then maybe these become a ticket in whatever system you're using. I mean, we're not really using a system here, right? So, but main is actually a better place to sort of put these things. So then later that day, you might come to me and say, Bill, I got 10 minutes. Is there anything I can do? And I'll just say, yo, go look in main.
Yep.
And see if there's anything there that you can sort of knock out, right? And if it's going to take more than 10 or 15 minutes, then I might say create a ticket in the system. Now, Mohammed's asking, could you please talk about pointer value semantics more? Will be wrong for these pointers. I'll bring it up as we're coding. I feel like the basic rules I've given you. Kevin, what are the basic rules for data semantics? Let's see if Kevin's been listening to me at all here.
Wow.
So, what are the basic rules for? I got him on camera here. All right, Derek, come on now.
All right, so
Just
we
the
want to
basic
use
rules.
value semantics when we're dealing with concrete data types in the structs, in struct types.
Or it may not be a struct. So what I want you to say is when that object we're dealing with is data.
When it's data, yeah.
Data, we're going to use value semantics. When the object we're dealing with is an API, then we're going to use
Pointer.
That's it. Most objects that are APIs are constructed once at application start.
Oh, okay.
So what's nice about that is it's just one instance anyway, and we need to share that API so we get the efficiency of the pointer semantics. It usually all happens at startup. So if we make a mistake where we forget to initialize an API or something, it blows up almost immediately and life is good. When that object is data, we want to really stay away from pointer semantics because all those crazy side effects that can occur as we're moving data, especially if we get into concurrency. And now we've got more than one Go routine trying to work with data.
It's better to work on the copies.
It's better for everybody to have their own copy and use value semantic mutation APIs and keep the actual data, which is what our program's all about at the end of the day, really is. It's all about data. In this program, the data we care about are the messages.
Yeah.
Right? Everything else is an API around getting a message and routing it to the right person. Those messages should not be using pointers. That's the data. Mm-hmm. So I'm not saying there aren't exceptions to this rule, but until it's obvious that we need to take an exception, we're not going to do it.
Exactly.
So now that we've done that, we'll have that conversation again next week. But we'll do that. I'll keep trying to bring that up too. If you do well on the data semantics, usually everything else sorts of works out. Like Rob Pike once said that if you get your data structures right, the algorithms become self-evident. If you get your data semantics right, writing that code also it just feels cleaner. And anytime you're dereferencing a pointer, it's already sort of a smell.
Yeah, something's going
Yeah,
wrong.
so you've done something bad. Okay. Sometimes you're forced because bad API design or something. Okay. So there's a whole bunch of negative path stuff. We did see some latency on socket drops. Remember?
Yep.
I did say don't judge me right now on the client because I know it's pretty ugly. But there's some other things that I wanted to do too. But let's do this first. All right. Let's go ahead and I'm going to bring this to the top here. Let's work on this real quick because I was hoping that we could just do it with the ping, but that kind of wasn't enough. And
Yeah.
we know that didn't work because when we killed the client and restarted it, it turned around and said, dude, you're already here. In fact,
Yeah.
let's see if we can simulate that real quick. That would be interesting to simulate, right? So what do I do here? I need another window down here, right? This is our project here. This is where I was running everything. And then here we'll do another window here. Okay. So we were going to run the two clients here. I think we're running this
Hack
hack
0,
0, hack 1, and then this down here was make chat run. So we've got our API here, right? And this was the problem. I'm going to try to do it really, really quick here. So if I do make chat this, we connected, right? And I do it again.
Already connected.
Yeah, but it's not. It dropped it. So the work we did with the ping wasn't enough. So let's at least sort of fix this problem right now. We know it exists. Maybe this is better served being fixed with tests and stuff, but I'm just having too much fun getting this stuff to work right now, so we're fine. Plus, look, now we just saw the ping, right?
Yep.
So now this will work, right? Like that. So, all right, let's go and look at our chat package. Where did we put that? We made it an SDK, didn't we?
Yep.
Okay. So we know a couple things. We know we just tried to do this handshake. And during the handshake, we tried to add the user. And when that happened, the user already existed. And we don't want to change this to necessarily drop the other user. I mean, a simple solution would be just drop what's there and add the new one. But let's be a little bit smarter than that. Because when that connection dropped, this is my guess. Listen. What happens in listen? Listen has this for loop,
Yep.
right? And if this fails, I bet you this would fail if the connection dropped. Like, I would imagine that we saw a listen read error here. Let's try to see if it's there.
There.
Empty message, right?
Yep.
And for me, that meant that the thing disconnected. So I would imagine here that this is a place where we could do a remove user. Now, here's a problem. We didn't add any information here related to the user we're dealing with, right? We just passed the con. And we did that because that's all we have, because after the handshake, that's all we did. So what this tells me is we've got to make a small sort of UI change.
Okay.
What this tells me is that we want to return this user back on the handshake. So let me do this for a second. Let's make a change quickly to the handshake here. If we have the handshake return a user, all right, because at first I didn't think we needed to do that.
Which I think we had it doing this
We did.
initially, right?
We did, but this doesn't bother me, dude. Like,
Yeah.
the fact that we have to refactor this again, it just means that we've sort of learned more. So I know now that that's our user, right? And then we come back here, and now what we know is that we got a user back. Okay, fine. And then what I want to do is, now this user doesn't have a socket associated with it. What we had here was the idea of a connection, and then what we had here was the idea of a user. So I'm wondering now if we want to attach these two things. I'm wondering, because when we call handshake, we're specifying this is the socket connection. And then we're going to bring back, here's a user. Now remember, they gave us the socket connection, right? So maybe this is going to be fine. Now, what I would do here, though, now this is where I go back to feeling like we're mixing concerns a little bit, because this is for marshalling and unmarshalling. When we do that, this WebSocket connection then is going to be sort of empty, right? And on listen here, no, we're using that. So let's play this out again, because there's a part of me that feels like maybe we can just do this. Let's see how it feels, right? Where we do this. And we'll just say this never gets marshaled either way. But again, this to me is a smell. I'm telling you right now, it's a bit of a smell to me. But because we keep stopping and starting, my chessboard's a little sort of weak in all the moves. So I want to just get a sense of what this sort of looks like. So if I do this, this will be a set of users. That's a user, right? And we turn around and we unmarshal the user. Now, here's going to be the funny thing, right? After we do the user, again, this is a smell, but we could do this.
Okay.
We already passed in the con, right?
Yeah.
So I could start with the construction of a user with the connection, and then we're unmarshalling, sort of the user that we're getting back. I guess we're saying as part of the handshake, we're expecting you to give us this information, right? An ID and a name. We're expecting to get your user information. So again, this is really all that's coming in. And then we kind of want this. So it feels a little ugly to me, but we're just going to keep sort of going at this here. So I'd prefer to do this sort of construction as opposed to what we had before. So you had two choices here. We could just say user, all right, do that, and then say user.con equals con.
Okay.
That's a smell to me, because what we have is partial construction. We're going to have partial construction anyway. But when I see these types of things, they've only ever led to like bad life choices there.
Yeah.
So what I would prefer in this case, again, this is why this is all smelling. Like we shouldn't need to be doing these things. We should have sort of different data types managing this sort of stuff. But this user type is what we're expecting to be getting back, and so we've done that. So let's just keep going with this. Again, this is a big sort of smell to me. But assuming that we construct it with the connection and then get the other two pieces off the wire, we now have that. I see some comments over here. Oh, do we need to export con? I don't know about any of that just yet. Right now we just have user in message and out message, but I don't think we're going to keep things like this. I'm just trying to get a feel for where this, I'm trying to get the chessboard back into my head here. So, okay, so that's fine, let's say. And now the point of listen was to get a user back, right? We're assuming that the handshake finished. You got a user. Now what we want is for you to do the user. And now if we do get a user, then we have the ID for this. We also have a connection. That feels incredibly well. Like that feels incredibly good to me that we have that, you know? And then this is still red. I did something bad. Oh, now we got to return a user. So watch this little trick I'm going to do here. Look at all those returns, right? So user, boom. That's that Command D thing.
Yeah.
This is why I keep telling you to get your hands off the mouse, man, and the keyboard. So we're there. Now, on Marshall, It's going to be, oh, this was message here. And then I don't know why I made that. Okay, so the handshake says, we're going to handshake and then you're going to get a user back. And the user is going to have a web connect socket. Now, that was the question. Do we want to export the socket connection? Now, I'm going to say yes, because this wasn't something that we created internally. This was something that was given to us. The caller already has it.
Okay.
So it's not like if we make it unexported, we're hiding something from the caller that they didn't already have, right? It's like you handing me something and then I'm supposed to pretend that I created it myself.
Got it.
That's kind of silly, right?
Yeah.
So I think it's nice to do this because then the caller can just keep the user if that's what they want to do, and they have their socket connection again. So I think if we're going to do this, then we for sure should make that sort of exported. Now, this is the out message, right? That's using our user. And this is really why I'm doing this. Because anytime we're going to be marshalling and unmarshalling, we don't want to, again, that's a smell to me, man. That just feels sort of dirty, you know? But I'm going to keep going with it. I'm going to keep going with it. So now this is our ID. This is our name, ID, name. And then this, the two, right? Now we get back a user, right?
Yep.
So we get back a 2. Oh, it's just con uppercase because everything's exported now. Okay.
And we don't have a connection anymore.
Yeah, we got to fix this too. Well, this is going to be a map of user, right?
Mm-hmm.
That's what we're getting back. Now, remember something with connections. I talked to you about it sort of offline. This connection stuff, all we really needed was the WebSocket stuff, remember?
Yep.
What is that type again? My brain just shut down. It's this right here. Okay. So technically, when I look at connections, really all we need back is this for the work that we were doing. And this will also minimize the amount of memory. Now we're just copying pointers, these 8-byte values, because really this says connections. That's all we needed. Why are we going to be copying the larger struct when
Got it.
I don't
Okay.
think we needed it? We're going to see where that's being used, but that's going to be our con. So now connections, really V is already the con, right? And the user information was already part of the map that we sent back. So you see how clean that is, right? It's a set of connections. What do we get? Con back, not users back. So that one I was thinking about sort of earlier. Then the add user has the user. And these are all now exported, right?
Yep.
Okay. And even add user, given a webcon and a user. Now, we could fix this now, right? Because technically now, when we call add user, we could just sort of, should be able to just do this, right? I mean, we already have a user, so we could just make a copy of that user there. Where do we call, so here's something we miss now when we're dealing with that. The only thing that we can do now is the ID, which we're getting out of K anyway. So who cares if it's not the name? We could deal with that situation. If the name was important, we'd sort of fix that. So look, the con is already in there now, isn't it?
Mm-hmm.
I like this refactoring so far because it's having us remove and or reduce code,
Yes.
right? So now we get a complete user with a connection. Now when we add it, it's already there. And then we could take that copy and store that copy into this. The pointer gets copied on the other thing. So everything is really safe right now with those value semantics. And then remove user given a UUID, right? Where is remove being used, right? It's being,
Listen. Well, we just added that one.
we just added that one.
Yeah.
Where else is it used? K. K is we only have the ID. We don't have the total. We don't have the entire user.
And that's used on the ping which was.
So I wanted
10
to see if we had a gorilla every time. Remember, I
Yeah.
call gorillas like those big structures. I was wondering if we had a user gorilla every time, and we don't. In some cases, we have a gorilla. Other cases, we have the ID. So I think this is the best ID that we API for that.
And we have that same there. Yeah.
Right. And so in this case, we're getting back the user. Let's fix this now. Right? We're getting back a user. And this was the user name. This was the user ID. Nice. And then this is the user con. And even that variable cleaned up, that starts making me feel like we're doing better things when we can do a refactoring like this and the variable names start to
It reads
sort
nicer.
of read better, right? That we're dealing with a user here maybe as opposed to a connection. So now I'm just looking to see if we've got any other variables, right? So this is, instead of V, what could we do here?
Same thing, user.
It's a user, right? It's the set of users. And, you know, this is the user ID, isn't it? So sometimes when I start working with a map, I do KV for key value pair because I don't want to necessarily slow down. But now we can come back in here, and I think we've sort of zeroed in a little bit more on sort of what this is, right? So this is our to user, our from user. I don't think we got to do anything there. And we've got our messages. So I like this sort of cleanup. This still feels, but the code is sort of cleaning. But I would still say this is a mix of concerns, right? We should have a type related to marshaling and a type related to needing this. But I feel like it's working right now. So for where we are, I think it's fine. And our ability to marshal it. Again, I'm not going to not keep stressing that this feels a little dirty. But then we'd have to define the other type again. And this just feels like it's working really, really great from a user perspective. I think if the caller didn't give us the socket connection, we could absolutely not do this. But if we come back up here, right, we're getting the socket connection here. How nice is that right there? Okay. So I think that's good. Now, remember I was talking to you yesterday about maybe moving that code into the handshake?
Oh, yeah.
Now, if we did that, then the caller's not giving us the socket connection anymore, right? So the only reason I didn't play it out is sort of because of the close.
Because of the defer.
So if we were to do something like this, we would then have to extend a close on the user. We didn't do it yet because that does have to get closed here. So this idea of like closing a user, but that doesn't feel right. You know what I'm saying?
Closing a user compared to closing a connection.
Yeah.
It makes more sense the other.
Right now, we could do something the same way the HTTP package does. Actually, there it is right there.
A user connection close.
Already has a close. That would be fair because if you do anything in the HTTP package, you do response.body.close. It's really the same mechanic. And since now it's there. Now what that means is, all right, we could do the following. Now, what that would mean then is what we're going to pass here is a R, and I would pass a W. So I would pass the writer and the request here, is what I think. Make it a little that way. So give me the writer, give me the request, and now I could assume this in the chat package, but that feels dirty to me. The app layer knows that the writer's in the context. The chat layer shouldn't know that. So that should be passed in. So watch this then. Could do the following. If I change handshake to not take a connection, but to take an HTTP response writer and to take a pointer to an HTTP request. All right. Then what can happen?
The space on the pointer there.
Yeah, we gotta fix that. Then what happens is, okay, now we have this WS thingamajig. The WS is this WebSocket upgrader. Now, what's interesting is that's being used in its zero value state from everything that I see. So why wouldn't that work then? I mean, we didn't initialize it. We just sort of had it in there.
Yeah.
So forget about this for a second. I mean, that's interesting. No, I can't do that. Okay. So we can do this though.
Okay.
Oh, because it's using pointer semantics there, and see how it's using pointer semantics?
Yep.
Assuming that's okay for an API. So let's play this out for a second here. Do that for a second. So if we do this, I construct an upgrader to then use its API. We now have the socket connection. All of this sort of is the same. We didn't need this after anyway.
Mm-hmm.
We were just using a single instance of it to do that. I can construct this. What's the big deal? Now we've removed some code here.
Yep. And there.
And now what you just have is handshake. Make sure you close the connection for the user. That feels good.
Yeah.
Then you listen. I don't care about error handling here at any level. Even though chat is at the SDK level for the app, it's nice that it's not importing anything from the web package. Okay, errors is fine, the logger is fine, but it shouldn't like be tied to the web package. That doesn't feel right. And we haven't done that. So I think this is super interesting now, the way this is.
Yeah.
And now we have the con by ourselves, which is kind of nice. And now this is another reason why we want to get it exposed. And they're absolutely right.
Defer.
Defer. Thank you. I would have seen that eventually. But thank you, Joseph. And now this is more of a reason to expose the connection. So this side of it can do the close. This feels really, really sort of good. Given a context, the response writer and the request, we can perform a handshake, and then we could just say listen here. And we can't combine listen. We could combine all of that into one call, but I like the idea that if the handshake fails, we can return an error,
yeah.
and then we go into the sort of listen sort of mechanic. So this is, I think, pretty nice right now. This gave us a little bit of a cleaner sort of API here, right?
Yeah.
And though this still feels wrong to me because, again, it's sort of mixing concerns between data that we're marshaling and unmarshaling versus data that we need.
Yeah.
I'm going to keep it like this and just continue to see how this sort of plays out as we go, okay? Now, let's double check that we didn't break anything. This is where it would be nice to have tests,
Yeah.
okay? Because we're refactoring. But remember how this all sort of started. It was wanting to, if the read message failed, to remove that user, which we now can. Also, if we're going to send a message, we already do that in here, right? Oh, we don't. So let's think about sending a message. When we send a message to the two, if that fails, then I think we can assume that they're bad too.
Yeah.
So we could just remove them as well, right? And drop that. And so I think what's nice here is on the listen, which is just this for loop, if that ever fails, and it will if the other side disconnects, we end up getting an error. It's an empty message, but we end up getting it. Now, one thing we could do, remember this is what I talk about tightening the screws.
Yeah.
There was an empty message, right?
Yep.
Now, I'm wondering, let's peek into the definition here. So that's a bummer to me. This to me is a API mistake. Why? Because we know that when the socket connection drops, okay? Oh wait, this is us. Oh, even better, dude. I thought this was the WebSocket package. So if there isn't an error, I'm just returning sort of empty message here. Does that make sense? What if we did this? Now, hold on a second though. The response comes in. So we read a message. What are we doing? Oh, that's right. We had to do this in a Go routine to deal with timeouts. So here's the read. If the read failed for any reason, then we return a response, and here we're checking it. So we should send this response out. Now, there may be something nice in there. So this is the connection. This is the function I want to look at. So here's next reader. I'm praying for some error variable somewhere that when the thing is disconnecting. And I don't really see that, right? I also see that they named these things, which is always super confusing. So there could be an error here. There could be an error in here. So I don't know enough yet what type of error we get when we drop the connection. It's not sort of clear. But this was a mistake. We should just send the response error out. Now, we could also wrap it, but I'm not going to wrap it just yet. I want to do the following. We've done that, right, which is on the read message. And if the read fails again, where are we here for our read? We're logging it, right? I'm super curious what this error looks like now. So let's run this again. I'm going to just move this up. I'm going to connect. We've now connected. What I'm curious about is
handshake read.
Right.
Ping completed.
Now, the other thing about the ping that we haven't done is we're not, now that I thought about it, we're not doing if we send a ping, they need to send a pong. If they don't send a pong, they're not there, right? So just while I'm here, I'm just going to put ping, pong, not getting one. We've got to sort of do that too.
Yeah.
We haven't done that yet. But let's come back here. Okay. I'm going to disconnect. Now, what did we get here? Completed handshake read. Okay. So we got that on chat 225, chat status 225. Let's double check chat 225. There it is, this read, which meant that, why did it say 225 in the chat? We must have logged that somewhere. Am I reading the right thing?
225.
This too is missing context, so we're gonna have to deal with that. And we did have a remove user 202. So we did end up calling this. Oh, dude, what is this context background stuff, man? What were we thinking? That's why we're seeing all that.
Context. Oh, okay.
This is like a rookie mistake here. I must have copied this from somewhere. So something else will go red now.
There.
This doesn't have a context. Oh, this is like rookie mistake, man. Can't believe I did that. You can see that our logs are all sort of a mess because of this. Guess what ping needs? Now, when we do the ping, we're not going to have a context here. So what I'm going to do here is just create a context. Well, at the end of the day, it's going to be the background context, but just sort of to keep this maybe cleaner, put it here. All right, just use it. This, of course, now, you know, we could create an ID other than 0 for this, but that's not important to me. But we know when it's 0, it's going to be the ping process. You know what? If Copilot did that, it's my bad for not reading the code. And this is the danger of some of this tooling. Because
We did it there too.
yeah, maybe it did come from Copilot, and again, I didn't take care of it. So none of that can be there. It's affecting all of our logging, right? So we have all that now. I think sort of, I got one more red marker up here, and that's because you need a context for that. Now, this ping is getting in my way in terms of logging, right? It's now becoming noise. And believe it or not, this happens sort of all the time. So for these types of things, we only want to log when
something bad happens.
is being removed, right? So ping here, ID, right? So we can do ping status send, something like that. We still got to do the other side of it. But at least right now there's nothing here, so it's getting in my way of being able to debug. So let's restart it. I'm gonna do this. I'm gonna hit this again. And we were looking for this. So starting handshake read, completed handshake read, fair enough.
Add user.
We added the user.
Handshake complete.
Now
And then remove.
Now I see started and completed handshake read twice. This is what I was looking for right here. On chat 91, unexpected EOF, WebSocket close, listen read, and we were seeing here, remove this user. And so I want to see chat 91 for a second. Okay, so this is exactly where I thought we would see what's going on in the logs here, right? And that's why we sort of see the remove user after. That was confusing for me in the logs, right? To see the remove before seeing the error.
Yeah.
So let's reverse that, okay? And then this is all about the error right here. Abnormal, unexpected EOF. So here's something interesting that we could sort of do, because we don't want to check these messages based on a string. It would be nice to know if there was some sort of error type or variable. Now, we could do a couple of things real quick to sort of figure this out. Because I'm vendoring everything, all right, I have the socket code there. Now,
okay.
I could look for abnormal closure, and if it's this 106, it appended that string to the error, close error, right? And then it kind of gave us a final string. Okay. And we see close 106. So here's the append for close 106, abnormal closure. Yeah, that ain't helping me very much. With WebSocket close. So that whole string that you see there is sort of being produced like this. Oh, man, that is a bummer to me because, well, maybe this is what we're getting.
Close error.
A close error. So let's try this out. if we're getting a close error, we're going to know right away. So let's go back and check this out for a second. All right. What if we said, okay, var, I'll just use v again. Close error, right? And then I'll say errors as, there's the error. This is the target. Now, I should look that up again to see if they're using value semantics or pointer semantics. They're using pointer semantics. That's good. So we'll be getting back a pointer to that. So this needs to be this. Okay, and if, now this would return, no, returns both. So if that is true, okay, then what we can do is, let's do it this way. If that is not true, then I sort of want to see the error.
Yeah.
If I know the socket sort of closed, then that's noise sort of in the logs, right? Now, what we could argue, though, is the following, all right? We're using the as. Now, you use an as when you think that this error could be wrapped.
Okay.
Now, I don't think this error is wrapped. So we could do something a little bit more here. And, you know, there's a good chance that read message, okay, let's do it this way. We own read message, we own send message, right? Okay, let's put this back for a second. All right, I'm just gonna put this back. Let's do something for a second. We own send message. We own read message. Where is read message? All right. I'm going to do the following. What's killing me is, like, I feel like read message should come before send message.
Yeah.
Okay, right? Like, what the hell? So there is the is close error function. Is that off of the WebSocket? Ah, look at that.
Is closer.
So they did exactly what I was about to do. They did a type assertion against the error. And if it is that, then they want you to specify the specific codes, though, right? Is it in our case, we were looking at 106 and stuff. Okay, I was going to follow the same sort of mechanic here. Look, is unexpected close, is close, there they are. But in this case, you have to specify sort of the code that you're dealing with. Now,
okay.
I'm feeling like at this point, I don't particularly care. Well, I do care if it was a But do I care what code it is, really, at the end of the day? So, look, you don't have to pass a code in.
Okay.
Okay, so this is brilliant. Somebody saw that. I was going to code this myself. But they've already thought about it, right? So let's go back to our read, because nobody should be reading without a read. So here's the thing. If there is an error,
Yep.
then what is the package name for this again? WebSocket. Then what we could say is WebSocket.is close error, response error. I don't have to specify a particular code.
Nope.
Now, if that's true, then what we need to do is send an error here at this point. Oh, you know, we could do the remove here too instead of doing it in these other things, right?
Do it there instead.
Yeah, let's do that. At the end of the day, if it's any sort of error, we're returning. And that's the read. We're going to be returning anyway. But if there's any sort of error, then we want, but only if it's a close error. Do we agree?
Mm-hmm.
Now, we don't have enough information to do that. So we would have to change this to be what?
User.
If that was a user, then that would be a user con.
User con.
And now you can do a remove user ID. But this is what I'm struggling with, okay? I almost feel like I don't want to do this check here. Like, keep this lower level. Let's keep this lower level. Let's put this back. I don't think that's the right thing to do. Let's keep this code lower level. So just return the error. Just like in send message, let's just keep it lower level. Let's keep both of these lower level, okay? Just keep them lower level. So it does the lower level send, it does the lower level write, and because of that, we don't need a context here anymore. We're not using context. Now, unfortunately, it would be nice if we could time out on a send. Maybe we could put that sort of back. The read was more important, I think, than the send timing out. But let's do this for a second. Okay. So let's go back to this read. If this returns an error, there's a couple of things that I want it to do. I want to know if the error is a close error. Because if it's a close error, we're done, right? What we can do is say, client disconnected, right? That's fine.
Yeah.
Do the remove, return.
Return.
Or, now in any case, we're going to do the remove. Agreed?
Yeah, because there's an error.
Now, we can do that way. I'd hate having the remove before the log, but whatever. We could do that. So there's an error. We're going to remove, but maybe this shouldn't be a return. Maybe this should be a continue. We can play that out. So why not switch up driver and navigator? I'm not sure what they're asking. At some point, Kevin's going to drive, I promise.
It's coming.
It's coming. Just got to get him a little faster. Now, see, if we do this, what are we saying? If it's a close error, then let's say client to remove it, return, we're done. Okay? We know it's closed. If it's not a close error, maybe it's something that we can recover from, and there's no reason to quit at that point, right?
Makes sense.
There's no reason to quit. So all of that is kind of cool. Now, there's something else that's bothering me here. If this ever fails, or this ever fails, well, if this fails, we just log it, we go back to the top. But we technically would have the same sort of scenario, wouldn't it? We should, if it's a close error of any kind, then we should be
Doing the same
thing or go back. If there's an unmarshal error for this, somehow, that means they sent bad data in. should we be quitting this loop, right? Should we be, probably not. I would almost argue too, we can't send it, and we're gonna fix this anyway. I wanted to re-queue this stuff.
Yeah.
But maybe we just continue. So this is the listen part. This is waiting for messages on a single user, right?
Mm-hmm.
And
Okay.
what we've decided to do right now, we're going to change it, is if that user sends a message, we unmarshal it, and then we attempt to send it to the person that they want to send it to. Okay? And if we get a read message and we've identified that the socket is closed for whatever reason, then we can just
Give
do that,
error
and we're
message,
done
remove.
listening because they're gone. And when listen returns, then that's going to shut this whole thing down because listen returns.
Got it. Okay.
Okay. If it's any other error, then we just continue back to the top of the loop and we get back into this read, and hopefully that doesn't cause us to be like, if we see it like an endless looping,
Yeah.
then we'll deal with whatever that error is. Now, if we unmarshal this message and they gave us something bad, well, we'll log it, but we'll just continue back. There's no reason to die. And then if we try to send it to the end message, now see, this is the problem. We're trying to send a message, but we can't do this because we don't know what socket we're supposed to be sending that on, right? We just don't. So what we're going to need to do is what we have, and we have to look at send message. We'll log it, but then we'll continue back up for whatever reason. So I think looking to see if the WebSocket is closed is important to check here, because if it's any other error, we want to continue going. If it's a socket closed, then we want to return. We could create our own error variable for this, but this package is already sort of married to the WebSocket. There's no reason for read message to create its own error to do this. And so I think this is fine. The question is, we don't use read message anywhere else. So if we keep read message raw, just do what you're supposed to do, right? It gives us the ability to time out on a read, which is essentially what we're doing here, or handle errors and stuff like that. That's why we sort of built this, right? So we say we're going to read on this WebSocket. We could have a timeout on how long we're willing to wait to read on that. Right now, what we've done is just said we're going to wait pretty much forever until the socket gets canceled. That's what this also does too, because if the socket gets canceled, we'll be here, we'll close this, and this will automatically just shut down anyway. So we needed to do all that stuff that day. But the send, okay, send is trying to send a message to this con right here. This is the con that we'd have to drop. This is the 2. It's the 2 that failed. So the question is this. Do we want to do the WebSocket close remove here? Or can we do the WebSocket close here? It would be nice to do it here because then you've got everything in one place.
Yeah.
But the problem is we don't have any socket information for what eventually is the 2. We don't have that until we look it up right here.
Okay.
So I don't think, now this is where things get scary for me, because if we start scattering things in different places and we don't do something consistency, like we're not doing this in the lower level, but we are doing this in the lower level. But we have to know if it's closed, get the hell out of Dodge. If it's not, then we just have to continue. No matter what here, we continue.
Yeah.
So ideally, I don't see a way. Guess what I need again?
Context.
Always need a context. Always need a context. So I don't see a way of doing this any other way. Now, let's think about this for a second. We tried to do a write, all right? Do I need to log in here though? No. However, I do want to send a different error to log. So maybe what we want to send here is write message. What did we call it here? What did we call it on the read when we checked it? Where is that? Let me steal this for a second. So just for consistency on the, but I don't want to log in this case. I want to just send an error. So let me do it here. I just want this to send an error. Essentially, I think we can do this.
Okay. Yeah.
And it's the two ID, right?
Yeah. 2 ID.
So in this case, there's no logging that goes on. We're going to write. If it fails, we're going to see if it's a close. If it's a close, we're going to remove the user and return this. Now, you see, my brain wants to do it up there is the real problem. But I can't. I don't have the information. This is where we have the 2 ID, right? Like, I want to do it on the other call. I just can't. I don't have it. So we'll just do it like this. We just don't have the information. So now what happens here is, and we're only, right now we're just sending a message to this one person. At some point there may be multiple people. So, okay. So I think this is going to take care of, we should see client disconnected there.
Yeah.
We could see client disconnected sort of there, right? So we could just even just make this client disconnected. Why does it have to be anything more?
And this should fix when you go back in that it's showing that you're still connected. You're already connected.
It should fix that because we should see that it dropped. So I think there's only a couple places where we do the send. That's it right there on listen. And this is the only place. So listen does everything right now, right?
Yeah.
It reads, Marshall sends. Read a Marshall sends. So this is where we're doing that. I want to do it here. Again, because if it's not a close, I just want to continue. I don't have enough information to do it here. I've got to do it in the send. Again, this is bothering me because if we're going to do it in the send, we should sort of do this in the read. But we have this. Now, what we could do is this, though. Let's go back to the read message. Oh, no, in the read message, we don't know anything here. We're just returning. Yeah, we know it on the right side. But you see, like, I feel like the API is imbalanced because of that.
Yeah, it's not.
Now, they are performing 2 different activities. If you don't send any code to the is, I think it always returns false. The way I read this code was this was optional. And so if it's a close error, it will be okay. Oh. Ooh, why would you make this optional? Thank you for seeing that. I assumed that that would still be a true. It just didn't match a code. So we were going to be in trouble here. What a really bad API this is. This to me is a bad API. Because
Yeah, they let you put a 0 or basically nothing in for
it's
a
a
code.
bad API. Because they said that you can send in one or many codes,
Yeah.
but if you don't send any codes in, then, oh my God, what a bad API. I didn't even think about the API doing that. And these are all the codes, right, that we saw.
Yeah.
So there's no way on God's green earth I'm going to be passing all these codes in. But I'm at a point where I don't care what the code is. You see, this is a really bad API. So I'm really glad to Mohammed for seeing that. But I like the idea of an is close function because we need it. So what we could do, okay, let me just see if we can write our own, right? And let me steal the code that we were already sort of, well, where do we have this already? Where is the listen here?
Listen there.
So look, we can't use this. It's a bad API. However, we could at least steal this for a second for our purposes here. And given an error, what do we want to know? We want to know if this error is a pointer to a close error, right? And if it's okay, return true, else return false. Come on. And this would have been WebSocket. This is what we want to know, right? And honestly, I don't even need it back.
You just want to know if it is or it isn't.
This is what we wanted to know.
Yeah.
And this doesn't need to be a method at any level. So sometimes what I'll do, because I don't want to add another file, is I'll just add another line here with a set of just functions. So what if we just did is con closed? Now, what does that mean for us? Okay. Means that we use it here.
Yep.
We use it here. Again, it's killing me that we can't have some sort of symmetry in here, but the only way to have symmetry here, well, what if we did this? Could we get symmetry this way? For a second. Let's say we pass the user. Okay, so that solves. Now, if the context does time out, we're actually, this is bad because we were closing it here. You see how we're doing things in different places?
Yeah.
And then you have a bug and you're trying to figure out where the hell this happens?
And it's hard to find.
This is horrific, okay? We've got to make a decision. It happens in the lower level or the upper level. So either we're doing these things because if this is the case too, what should we have done?
Remove user there.
We should have removed the user here
Yeah.
too. Which we couldn't do because we didn't have the user. Now we've got the user. We have to do the same thing here, okay? We've got to do the same thing here. But if the response error is closed, then what do we want to do? Well, it's already closed, so we don't have to call close. But we definitely have to do that. Now, this is where things get sort of tricky again. Remember that we could get this error, which means the context timed out. We could get this error, which means we had some error on the socket. Though, what I've kind of learned already is that if there's any error on the socket, there's usually a big problem,
Yeah.
okay?
Yeah.
So I'm wondering if we're complicating our lives here, okay? I'm wondering if we're complicating our lives. Who cares? Is what I'm going to say. Oh, but I didn't want to see an error in the log that we were doing that. But I'm complicating my life over something that is fairly insignificant. I've wasted all this time on something that technically doesn't really matter. So look, we do the handshake here. Oh, look at what happens here. So we're going to need to move this up for the user, because that initial read message needed a user,
Yeah.
right?
Yeah.
And then we kind of fill in the blanks there. The rest of that information is going to be empty. But that's fine, because we wanted the user anyway just to be able to. Now, we don't have an ID at that point on the remove user call. We'll deal with that. So if this times out, whatever error. If this happens, which will always happen, there'll be an error. Okay, fine. I almost want to put back my little, but we're going to do this again anyway. That's fine. On the remove user side, now we have the chance to have a 0 value, sort of that, because in that one handshake call, right?
Yeah.
So what we can do is say if user ID equals
0 value.
Yeah, I didn't think I could do that. How do I check that without creating a new variable? Just return, right? I thought, oh, the UUID
No.
package has a not an invalid, but an empty or something. I know the UUID package has.
A nil or
It has something, oh, nil.
a nil?
Yeah, nil. Okay. So if the user ID is nil, just don't even bother, right? I hate these. Remember, these are the if statements I was talking about a little bit in class. If you've got to do things like this, but now we know that we might have a situation where we're in that sort of code path. And now, technically, we'd never find the user. And we would come here and say the user doesn't exist. And, maybe that's fine, actually.
Yeah, I mean,
I would like to see that in the logs if that sort of weird handshake thing happened. So maybe we're fine there. I think we are. And now you're going to read this. And now what we do is we come back here again and just say, do I want to? So now I have no choice here. Now what I think we're going to have to do is basically say if exists error, and remember what the type is. Okay, so if it exists, okay, we're not going to do a remove user, but we're going to just log it differently. So I could do the check just so my logging is a little bit sort of cleaner, right? My logger's a little bit sort of cleaner.
okay, yeah.
So if it drops, then that read message, and we should see client connected and will return as opposed to. Now, we've already removed the user though. So, me and else clauses, I freaking hate them. But what we could do
Is a switch?
is a switch error type. Okay. So I hate else clauses. Anybody watching this? I hate else clauses. So we could do that. It's getting in my way now. Default, sort of that. And then this could be the return. And then that is a continue, right? And I don't even need V because I'm not using it. So you see there, we could use a switch, and we could say if it's a WebSocket, pointer to WebSocket close error, then do a client disconnect and return. Else just write that and continue. This is cleaner.
I like that.
The deletes are happening at the lower level, and sometimes you will want to know what that is or not, and that's cleaner. And so we're removing users. Now, we could have a context error. We could have, in the context package, there's something else we could check. So we can say case context dot, it's a deadline exceeded, but I don't think it's deadline exceeded. That is an error, might be a pointer to it. We can double check that. What is it complaining about? Yeah, it's not an interface. What does the context package return again? Let's go look at something here. No, I just like to peek in there like this. There are some, you see, it could be canceled. But that's a variable of this error type here. It's not, but yeah, it could be canceled. So I think we can do, where was I? Case context dot, no. Why is this not working for me? This is an exported variable right here in the context package. It's called canceled. Why am I not allowed to
CTX instead of context is a CTX?
No, because I want the type information for this. The problem is that I'm asking, is the concrete type stored inside of ERR or pointed to a WebSocket close error? Or what I want to say is it this? But see, this is not a type compile. This is a variable. Oh, because it's not a type. Oh. This is going to be an area. See here, I've got to, this is the bummer now. What I almost now have to do is say if errors is error context dot canceled. Okay. Then, like, kind of what do I want to do? The only reason I would want to be here is because I would want to say that the context timed out. So again, I'm about to make things more complicated for some logging stuff that isn't necessary because we're not setting timeouts anyway on that stuff. But you can see how this package is doing things with concrete error variables in a sense, and the other one was using a concrete a custom error type. And so this syntax worked really good with custom error types, but it doesn't work when we're dealing with these sort of error variables because that's the type. Now there is a type here called deadline, but it's unexported. You wouldn't be able to do that. They've implemented a lot of this stuff for themselves. So, but we don't need it. I think we're fine here. Well, we either get one or the other. I think we're fine. But we just have to remember that we could get an error here. And the problem, okay, so this was my problem. This is why I kept going back to it. If we do timeout, then when we remove the user, I didn't really want to go into a continue. I want to return. So I really do need to, regardless of whether we're timing out or not, okay? I really do need to say errors is, if the error is a
context
canceled. The other option is just to say again, if, so we got two ways to do it, right? You can do it this way. You know, if we got an error back because the context was canceled, we could do the same check. I feel like that's dirty. I feel like the better thing to do is the is and check it this way. I know it's the same context, but because if this is the case, I don't want to continue. You see what I'm saying?
Yeah.
I want to do that. Now, there's a lot of code there, right?
Yeah.
This whole big switch. Now, it's only being used here, okay? We're not using it anywhere else. We're not checking this. So there's a couple problems now from a readability standpoint. This is kind of getting in the way of readability, right? read message error, this. It was much simpler before. We've now got this big block of code here that we're using to determine if we should return or not and what to log. So what if we just wrote a function again? Read error, given an error. And maybe what this does is return a bool to determine whether it should return or not.
Okay.
Okay? And we make it a method so we can access the logger. So what if we did this for a second? So in this case, we return, now we can call it is read error, but we already know there's an error. So really this is,
It's more like what type of error it is, or which.
more, is it a critical error? Critical read error. I don't know just yet. Did I spell critical right? So if it's a critical read error, then we can just say true, true, false, right? Also,
Context.
I always say content. We can do that. So this is interesting, right? Because now,
We
watch
can
what
just
happens here.
Call that.
Right. And we can say if
And that's all gone.
that just
Much better.
from a readability for this sort of business function, now we can see again in a single line of sight, read on Marshall send, read on Marshall send. And if it's a critical error, then now we can even make this even simpler too, right? Because, well, we do need to check if it's there. I thought maybe we can get rid of this, but we still would need to know if we're going to continue here or not.
Yeah.
But this is really nice now, right?
Now
Is
that got
critical
moved.
read error. And a critical read error, if it's true, then we want to return. And now we've got the ability to sort of check these sort of errors again,
Yeah.
And-
I
and-
like that better.
right? And really, we could just say is critical error because technically we could use it on the right side too if we sort of wanted to, right? But again, once we're in the send, we're killing somebody that we don't sort of know. Remember,
Yeah.
this go routine is the go routine handling this user. So now I'm wondering something. If we just focus on the read side of things, we're going to be able to clean everything up
Okay.
because we'll have a go routine for each socket connection. If I can't write to it, we couldn't read to it either.
Oh, okay.
You know what I'm saying?
Yeah.
So we don't have to, I think, worry about the send side of cleaning things up. Just like if that fails, we just say, okay, dude, whatever. We'll log it and we'll just keep going because you may not be there, but I'm here.
Yeah.
But then the go routine that's handling that socket or that user will end up failing here anyway, and we're going to take care of it, right?
Yeah.
So I don't think we need to use that remove anywhere else. I'm going to do this again. I'm going to see where this remove's being used. And here, it's just on the read message, right?
Yep.
If we get a timeout, I'm forcing a close on the socket auto-magically, but doesn't remove do that? See? We don't need this.
Yeah, it already closes it.
It already closes it. It already sort of closes it. So, wow, the ping. I would say again, we don't need to remove this on the ping. Now that we're handling the write correctly, that was a
Yeah.
mistake. What I would do though is the log, right? Actually, do I even care? I mean, I've got reads, so do I care now? You might argue that I would like to see it if I couldn't, right? Let's just put a log in. I don't know if that's going to be noise or not. But I definitely want to close or do anything. We'll let the receiver side sort of do that.
Okay.
All right. And see, what I would even say to you is, we need the Pong side of this ping,
Yeah.
right?
We do.
Now, there may be cases where we're worried about is the ping running, in which case we'd want to log, but you saw all the noise.
Yeah.
What I would prefer to know is that we've always got people connected. And so if we just log failure stuff on the ping, right? At that point, we've got to come back here and say, I think we have to receive the Pong. We got to look at that protocol again. It might be inherent in the WebSocket stuff, and I don't have to worry about it. But, you know, there may be, remember when we saw those functions? That was a con. Oh, I'm just doing IntelliSense here for a second. Set close, set Pong handler. Right. We need to set a Pong handler. So when we do this, right, we set up a way of saying how long ago was the ping, and then check to see if we got the Pong. We're going to have to come up with a ping pong sort of mechanic.
Okay.
But we're going to have to read more. But I think if we send the ping and we don't get the Pong, we need to drop that connection. Like, you got to go.
Yeah.
And so we'll have the set on the Pong side. But I already added that to our list of things. But you can see there's a function there. So that's kind of cool. So, but we've got to tie the two. Now what you have is what we call an asynchronous problem, where you've got this one Go routine doing a ping, a different Go routine is going to get a Pong, or it might not get a Pong.
Yeah.
And this guy now needs to know, did we get Pong? So it's almost like this, right? It's going to be like, check to see if we got Pongs for the last set of pings. We may have to do it here. So we're going to have to set up a little more infrastructure where the very first thing we do is, okay, for the pings we sent, and we record what those pings are, did we get back a Pong? If no, blah, 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 blah.
Got it. Okay.
But we should read up a little bit more on that sort of protocol too. Okay. It's not going to be today. It's already an hour and a half in here. Oh, I never put it back. Yeah, I do that all the time. So I'm pretty happy now with where we're at here. And it should solve the connection problem with the right logging. So
Yeah.
let's try that. Then we'll push some code out to the masses here. All right. So if I connect, we can see here starting handshake read. So we're in a read. See, that message is wrong. If I see starting handshake read,
We're in read message starting.
oh yeah, because it's blocked in a read, but this is the problem. That sort of message is the problem. So I don't
okay.
like this starting read. I'd rather in the log say waiting for message,
That would
right?
make more sense.
Now,
Okay.
the problem though also is that this could complete. The only reason I have logging in here is because I've got a Go routine and I want to make sure that it starts and stops here, right? So message read complete. But then, you know, there could have been an error or something related to that as well, right? We're getting that error sort of here, aren't we?
Yeah.
So as a couple things we can do here, if we wanted to do that. If I did this, then
Okay.
this error will be this, and we'll capture it on the defer.
All right.
And kind of
Yeah.
close over it. That way, at least we know on this go routine, we could say waiting for message, right?
Yeah.
And really, this is, okay, so this is chat related, but maybe we do chat, read message, it will give us a better understanding of where we are here. Read message, status started, status completed. And we may or may not have gotten an error with that. That to me will feel better sort of in the logs, right? So
Let's see.
we see that, and then we connect, and you see now it says read chat, read message, started.
Started.
You see here, completed without an error. So we know that go routine as part of the handshake did that. Now here's the key. We drop, and what do we see here?
Client disconnected.
Read message completed. We see a remove user because the client disconnected, and we had removed that user, and we're done. That worked
Yeah.
really well, didn't it? Because now we can
Yeah.
come back in and connect. There we are. And this is beautiful. We're starting to be able to detect now when that client drops, and we're cleaning up after ourselves sort of perfectly. And again, we've been struggling all day with where we should be putting things and what should be doing what, and trying to minimize the surface area. So I think by doing this in the read, because that's, remember, we're blocked on the read, we're going to know on any client connected what's that happening. Our concern isn't on the failing of the send. The other go routine should deal with the read. And now we've got some nice logging too, because if you go back and look at, that was the handshake, is critical. We now know, wait, client disconnected. Yeah, right? It wasn't like an error. Like, all right, we detected that the client
just disconnected.
All right, what was that var error on line 39 again? So what we're doing here is when this defer function runs to show that this go routine terminated, we want to see the status completed. Anytime I'm launching a go routine, I want to see this. That go routine started, that go routine completed. But I want to know if there was an error that occurred, say, in here. And so the idea here is that if we declare the variable first, then we should be able to close over it. And when that fails, we should be able to know about it. Now, if I look, now maybe it's not working because when the thing completed, it said nil, right? So we may not be properly sort of, let me try something here. I really want to close over this error so when it gets, well, the idea is that message is a new variable. It should reuse error here. And this error should be this error. Let's try it again real quick. You may have found something. But the short variable declaration operator should have been fine on that. Oh, now we see it. Status completed. So now we're getting, I'm logging why that sort of went out, right? It was a disconnected, but I know what it is. So when I didn't wrap this around a function, we didn't get the closures that I wanted. It was already using error set to, this is some weird Go stuff, right? So if we just said defer the function, then it was taking the value of this variable at the time it was setting up the code for the defer. But if I wrap this in a function, now what's happening is we're closing over the variable. And then when the function's executed, it will be the value of.
Oh, okay.
So
okay.
that's why before it was nil,
Yeah.
but now we're actually seeing it. And I don't know if we need to see the error, but I have no other way of knowing. But we are going to get it here, aren't we? So I would argue that maybe it's not important to see that error. The whole point I've been working all day is because I didn't want to see an error that I knew wasn't an error, right? So it might just be enough for me to just say, I want to see started, I want to see completed, I want to know that that happened. And then the rest of the error handling will kind of give us that information. So I don't need to see this in the log. That's noise because I know that equates to sort of this, okay? But what we were doing is I didn't set the closure up right. So even though that variable was this variable, at the time the defer was evaluated, it was using ERR based on what it was.
Oh, okay.
Then when I wrapped it around the literal function, it wasn't evaluating ERR at the time of the defer. At the time of the defer, it was evaluating the literal function. And then when that literal function executed, it said, well, what's now the value of ERR? Little weird stuff,
Okay.
right?
Yeah.
But it was Mohammed was good at sort of pointing that out. But I don't think I need any of that. I think this is enough from a logging perspective. I know that we started that go routine. I know we ended that go routine, and we know what happened on that read. We know that it was that. Yeah, for sure. I didn't get the closure I wanted without using the literal function. I always use literal functions for that anyway, so I guess I get lucky a lot. I'm doing that. Okay, so I think we should do a couple things here. This messaging is bad, right? Like, if we want to be consistent here, chat, I can't assume this was in a read or not, right? So, I don't want to say is critical. I mean, we could say is critical error here. I don't mind doing this type of stuff. We're not a listen read anymore, are we?
No.
No. So, I think that's fine. We can just have that in the log. And this, yeah, sometimes I like putting this prefix chat because that will also tell me that we're in the chat package. We're in the listen function.
Yeah.
And this was an unmarshal problem. This was a send sort of problem, right? On the errors, we don't do that because we're going to return errors. That's fine. But on anything related to the log, here, handshake complete on the log, right? If we're going to be smart. Now, even here, handshake complete, we probably don't need to be logging that, but I don't know if we need to log it. I feel sometimes like if we wanted to log that the handshake's complete, we should be doing it here. Like, I don't necessarily need to see that unless, but this is gonna handshake fail. So, you know, I'm questioning if this log line adds any value, but let's say we're gonna keep it anyway. So then this would be handshake, you know me with my status. But for me to have a complete, what kills me is then we don't really have a sort of started, but we don't need a starting complete here because this is not on a new go routine. So, but let's just say we keep that for now. We can get rid of it. That one's good, that one's good. Right, this is in its own loop.
Yeah.
So we can't do logging at the caller side, that's fine. Chat is critical. Chat read message for some of that logging. We don't have any other logging anywhere else here. This we do here. So we're gonna, again, we're gonna have to fix that very soon.
Add user.
So chat, remove user, chat, remove user, just for consistency here, right? That's fine.
Add user above it.
Oh, all right. Chat, add user, that's fine. Okay. I think so far this is some good logging here. I want to push this code up. And let's see what we've got here. Get status. we didn't really add anything, right? Git
No.
commit minus am. Sort of cleaned up client disconnect. I mean, all this work all the work that we did today was around cleaning up this code for client disconnects.
Yeah.
But by trying to work on that problem, we now you see how I did this, like from a code readability standpoint.
Mm-hmm.
I would much rather put these in sort
Like
of a
that.
var block. So you could do type
Okay.
blocks and var blocks, and I tend not to do type blocks at all. But when you do have something that's really the same, like error variables, I think that's nice. Now, these are exported variables. So technically, from a logging perspective, they should have sort of comments. But one thing you can get away with is just putting a comment sort of up here, right? And it would attach to like everything
Both of them.
related. Yeah.
Yeah.
You could just say, set of error variables. But if you wanted to document these, you could put comments in here. I just always like having a line space above a comment. So that's that. I mean, what we should also do anyway, let me take something from, I thought I ran service. Let me take something from the service project real quick. Even though we're not in a position yet to sort of run tests. Where am I here? Oh, okay, hold on. I got it in my other window, but it's okay. I'm just gonna pull it really quickly because at some point we're gonna do this stuff too here. Okay, come on now. Test, there we are. Let me bring this section of things into the make file. We're gonna have to start doing this stuff anyway at some level. We don't need that. But I have these in all of my projects. And essentially, the ability to run, make test. So
Okay.
test only, see I'm disabling CGO for that too. Check the linter, and then a vulnerability check. I'm kind of interested if we've been compliant on the linter side, to be honest with you. So let's see here. Make lint. So the majority of these linter issues are what? At least one file package should have a comment, chat
Oh,
app,
okay. Comments.
right? And it's not going to complain about missing comments on exported identifiers, which I think is good because I work on some teams that I cannot get anybody on the team to write comments. So I've almost made it now a thing where just give me the comments that static link wants, which is essentially these package level comments, right? So
Oh, okay. Like
actually,
package.
yeah, Copilot's not bad with these, but it has to start with the word package chat app. Okay, so we can do that. What do we got? Model. So this is model at the chat app level. Now we don't need it. We only need one file to have the package directive. So we've got that there, but it's complaining that we've got status unused, status and code unused. We're not using status in, we're not using any of these models,
No.
are we? So, yep, that didn't belong here. Okay, good. And we're not using any models right now, are we? Because we hid everything inside the chat.
Yeah.
So we don't need that. Yay for the linter, right? Let's get rid of some more code. And then this won't complain anymore because we've got it in the other file. So if I run the linter again, now it's just mux.
Mux.go needs comments. Yep.
Package mods provides, just say routing support, something like that for now. All right. Now we're clean on the lint. We're clean on the vetting. Another cool tool that Go has, and now that we're running 124, is the vulnerability check. This will start to fail when a new version of Go, even a patch version, comes out. We'll just check that all of our packages are up to date and stuff like that.
Oh, okay.
So at least we've got that. So let's commit this with sort of linter fixes. And we're good. Okay. So let's go back to our main.go.
chat, API, services.
Okay. So I'd say that we knocked out that.
Yep.
That's very cool. Looks like Florin just joined the, finally, Florin. Oh, now I'm going to be nervous again. Florin, you missed all of the good stuff. Remember, we got like 20 minutes left today, though. All right. We have the basic chat working. That is true. Our client is in really bad shape. But let me think about what we want to do next. I think, so there's a few things that I want to do sort of next.
Refactor client.
Yeah, we got to refactor the client. and we could do that now, but let's just hold on there. I want to relook at the ping pong stuff, and I need to understand it. So what we're going to have to do, and let's do this in the next show.
Okay.
Write another hack program
Okay.
that gives us the ability to fully understand the whole ping pong mechanic.
Okay. Yeah.
Because if something doesn't pong, we should drop it. But I don't know if this WebSocket package already does it if we set certain timeouts. So if it's already supported in some level, we just need to log what's happening, that's great. But I don't know enough. So I think what we need to do is, remember, every time I'm trying to learn something, I just write a small little program.
Yeah.
We
and
learn
see it work.
And then we can figure out. We got to do that. Now, I do want to talk about cap to cap communication. And I want to set this up in 2 stages, okay? I want to set this sort of up, I'm going to call it internally with our own queue. And then I want to use NATs. I want to do this multi-part. One, because I just want to understand from a code perspective what happens when we decide that every message coming in the system will be placed on queue, and another process reads that queue to send messages out. Let me diagram it. Let me show you where my head is.
Okay. That'll help me
Okay.
out there.
So this is kind of what we've built today,
Yeah.
okay? Where this package, these things are kind of in that one chat package.
Yeah.
So what happens today? Okay, let's go deeper now into looking for a good place. What happens today with chat? All right. Well, we have this go routine. This is at the HTTP level, right? So there's basically a go routine that comes in with a request. Here's a path of execution. And what do we do with our chat package? Well, we call handshake, right? And the handshake upgrades this to a WebSocket and then does the communication back to, let's just say, some sort of client here,
Yeah.
like our nasty client, that for our purposes is talking to this go routine via our mucks and all that stuff. Okay. Then after the handshake, what happens? So the handshake, we end up in a listen.
Yeah.
Now, what does listen do? Listen essentially blocks on this go routine.
Yep.
So it's not a new go routine. It blocks on this go routine, right? I'll just maybe do this, where we've kind of now moved sort of here.
Okay.
Now,
Yeah.
what listen does, it's in that for loop.
Yep.
And what it's trying to do is it's waiting, right? It's in a read message. And that is a blocking call.
Yep.
We've learned how to detect when that returns for failures and things. So it reads the message, and then basically unmarshals the message into that, because we're getting JSON back. All right. And then this is the part that gets interesting, because in this part here, we call send message.
Yep.
Now, if I follow along the way I'm doing this for a second, okay? Let's just stop this sort of here. All right. Send message now has part of that router logic in it, right? What it's doing, it's saying, okay, I already know who it's from, technically. Let's take a look at that code again real quick. App, SDK, chat, right? Send message. Okay.
There.
So it says from to. So basically it does a lookup for from, right?
Mm-hmm.
And it's looking up a local map right now. It does a lookup for to.
Yeah.
Again, what we're trying to do is get sort of sockets. Now, I don't know if it needs to do the from lookup anymore. I mean, why are we doing the from? We know the message came in.
It's
right?
more like where is it going to end up?
But, yeah, because let's take a look at this for a second. Where is this called? Send message again called. It's here, right? But if it's to be in this loop, if it's in this loop, we already know who it's from. We already know who it's from. So what's interesting to me is when we do this inbound message, that's redundant.
Yeah.
Technically, it's redundant. We know who it's from. It's on that socket connection,
Yeah.
right? So we could do that. On an outbound message, okay, where it's going back to the person that we're sending it to, we could make an argument as well that we know who it's going to. You received it.
Yeah.
I mean, you know who you are. So technically, inbound messages, we need to know who you're going to. We already know who you are. Outbound messages, you just need to know who it's from.
Mm-hmm. Yeah. Okay.
Okay. So in this case, then, we already know that that's the inbound message, right? This was from this user here. Let's play this out. I don't need the from anymore. I just need the to. And on the outbound message, you just want to know where it's from. We know who is getting the to. Right?
Mm-hmm.
So there was some redundancy there that we didn't really need when we sort of think about it. We don't find these things until we start trying to diagram and model, but that's sort of clean, right? Now, just because we're sort of here, this was our hack client, right? We got to finish our diagramming, but what we just said is a inbound message. Inbound message, we don't need the from.
Yep.
We know who it's from.
Out message, we need to know.
We don't need a to. And we don't need from. This all should still work. And you just need a to, I think. We may have like broke this, but we need to fix it anyway. All right.
Or
Yeah, I think this will work.
okay.
We'll try it one more time before we're done in 10 minutes. But if this is broken, I'm not terribly. It's all yellow, right? So we're good. So that's the inbound, and then we have a go routine reading the outbound. So that's going to work. But let's go back to our diagram here. So we don't have to look up the from. we have to look up the 2. All right, so let's go back to, we look up the 2, and then after we look up the 2, we essentially send 2.
Okay. Yeah.
Okay? We send 2. That's what we're doing. We already know who it's from. Do that. We put the message up and we send it. Okay, this is what we have. And what we're basically doing is on this go routine, and we can have 10,000 of those. Each one of those, anytime it receives a message, will go through these steps for itself. And this is fine, and this will work, and it is working. But Kevin can drop a link to the playlist. But remember where we wanted to get to. This is the process of a single sort of cap, right? Client access point. I want to get to a point where I've got a cap here, I've got a cap here, I've got a cap here. And we got somebody connected here. We got somebody connected here. We got somebody connected here. Right now, our server works when everybody's on the same cap. And this process works when everybody's on the same cap. What we need now is some sort of, I draw it as a triangle, some sort of message bus here. What I want is this cap connected to this cap connected to this cap connected to this. And we've got a couple of choices here. You could keep this process and decide that if we come in and we find another user on the same cap, just go do that. That works. If we don't find the user on this cap, then send the message to this bus, right? Send the message. I wanted to write that really small, but I don't think I can do that. Oh, they got a small font there. Good. Then send this message. Be nice, be kind. Send this message to the bus. And let the bus ask, right? So we send this message to the bus. The bus sends the message here, sends the message here. And it can do a lookup and then do a send. And then later on, you can have redundancy in this and yada, yada, yada. But this is the way I think about things. And we've already seen it. If we can just keep one process and put things in one place, like we were doing with removes and stuff, then it's going to minimize where we have to look if there's bugs.
Yeah, easier to maintain.
So what I would love to do is this. This is what we're doing today, right? Let me take a quick capture of that. This is what we're doing today. What I would like to do is this. Let me bring this down to, we'll bring this down here. What I would like to do is this. When we're in a listen and we're in a read and an unmarshal, let's not do this. Let's just do one thing. I'm gonna make sure I'm back in my medium font here. All right. What if we did this? Push message. In other words, we read a message, we unmarshal it, and all we ever do is push it to the framework. Let's not look on our own system. That's all we do. That's nice and simple.
Yeah.
See, because then what we can have is a separate go routine. Okay? So we can call this the read go routine. We can call this the send go routine. Now, what the send go routine is going to do, as you can imagine, is essentially, however we do this, but let's just say that it's able to basically sit in a, we'll call it a receive message. We use signaling semantics. Or we can call it receive from bus. So it blocks on a receive from bus. And then when it gets it, if it gets a message, right? This could be a polling mechanic where it's like, is there anything for me? But let's say that we can make it more of an event sort of thing that happens, a signal. Okay. Then what we can do is what? We received it. Now what we do is we say, look up 2, right? And then if we find it, let's say, if we find it, then we can do a send.
So instead of doing it all off of the read go routine, now it's going to be a...
Instead of doing it on the read, we separate these two things. Even if that client's already on our cap, the system will be fast, and we've sort of said one thing. Now, if the performance starts to degrade, we can add this complexity and say, do a lookup first, and then if it is there, but I still don't want this go routine to do the send. Okay?
Yeah.
This would be nice.
That way it's all separate.
Read on Marshall, push. Read on Marshall, push. I don't really care if it gets any air. We're just going to do this. I just want an acknowledgement that the message bus or the queue has received it. And then we received a message. Do we have that client? Send it. If not, throw it away.
Got it. Okay.
Okay.
Yeah, I see it.
Now, remember, you could always get more and more complicated with geography if we knew where somebody was and we had to do smarter routing, but we ain't going to get that far. But I'd like to do this. Now, eventually, I want this to be NATS. Okay?
Yes.
And NATS already has a public playground that we can use to do this. So we don't have to run NATS sort of locally for this project. Though we could, right, in a Docker container. NATS already has like a public sort of playground for this. I got to ask David Gee how to gain access to that again, yada, yada, yada. But before we introduce NATS, I would like to build an internal version of NATS, real simple. Basically our own message queue. We can use channels because we're not going to live on it, but we could get this logic working. And then when it's working, it's a matter of swapping that out
and putting
for NATS.
Yeah.
Yeah. And now we can have a cap running on your laptop, a cap running on my laptop. You can be connected to yours. I could be connected to mine, and we can still talk. And it's going to feel bop, 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 bop. Anyway,
that'll be cool.
Even over the internet. So this is where I want us to get to. And so I think when we get back, what is Thursday? So on Monday, or Tuesday next week, I want to solve this problem. I want to get this one sort of out of my life. Let's really figure out what ping pong is. And then we're going to do this, and then we're going to bring in NATS, and we'll continue to refactor. And then at some point, if I put this in some real priority for me. But let's do one thing. Let's just make sure that we didn't completely break our little client, and then we're going to finish up today. So I'm going to do the make, what was it, make chat run?
Make chat run.
Let's just make sure we didn't completely blow everything up here. So this was make hack 0. This is make hack 1. I'm going to say, hello, chat 0. Yep, hello, chat 0.
Cool.
Hello, chat 1. So we didn't break anything. And it showed you that we didn't need the to and the from
Yeah, yeah, it
and
was
the other
redundant.
things because we already sort of had it. And I think this logging could get better. I'm starting to think that this is sort of noise, right? This right here, that's noise. I'm gonna get rid of it. It's already like driving me crazy. So sometimes this is why we need to be using our logs. We might not only need logging when things are failing. I'm just gonna get rid of it. Because if we look at this again, and we kill this, clean it up, run it again, and run it now, hack 0, hack 1, hello chat 0. The logs are much cleaner now, right? Now, there is a problem ever since I got rid of that. Hello, and we're gonna fix this. I'm gonna put in the notes. There's no logging going on when messages are back and forth.
Oh, okay. Yeah.
We're sort of blind now. Oh. So what we're gonna do is add one more note before we shut down our little thing. And we'll do this first. Need logs for messages incoming and outgoing, okay? Because now we're blind that any of that communication's happening. The log I had there was noise, but we gotta do better than that. Okay, we're good. I'm gonna close all these files. I'm gonna do one last sort of commit here. Git commit -am, sort of final notes. Git push, boom. And I'm gonna come back to our little world over here. Oh man, we had a good day today, dude. We got some nice code. It's cleaning up. We're getting close to being able to bring in our sort of Nazi thingy to do cap-to-cap communication. I've added some notes for us to remember on Tuesday. Tuesday's going to be here before we know it. Isn't that always the case?
Yep.
But we're all going to have a great weekend. So you've got that code. You could take that, and we're going to have to do some logging cleanup as well. So I want to appreciate everybody for hanging out with us again for a couple hours. Hope you learned something. Enjoyed that time. Thank you. Kevin, anything else you want to say?
I appreciate everyone who joined in, and this is all about learning.
Look at the camera right there. Look at the camera.
This is all about a learning process for me and for Bill too, and we're learning off of each other here.
Yeah.
So it's exciting. It's
All right.
exciting.
Everybody have a great weekend. See you next week.